In this section, we're going to look at how we can generate binary numbers using a queue data structure. And we're going to write a Python function that is going to take in n. Basically, it takes a number n and generates representations from one, binary representations from one up to the number n that a user is going to specify. So we're going to basically use a curator structure to make this a bit more efficient. So an example, by the end, if we put in 5 as the value of n, we should be able to get basically a queue that looks like this, that contains binary representations, right? So let's jump into writing the code on this. The first thing we're going to do is we're going to first of all import a queue, or rather import the queue from collections. So going to say from collections import the queue from collections import DQ. So we're importing the DQ data structure from Python's collections module, and a DQ, or in full, basically a double-ended queue, is an optimized queue implementation that allows for fast appends and pops from both ends. So we'll be using the queue to manage the queue that will store our binary numbers. And the next thing we're going to do now is our function definition. We're going to call our function generate binary numbers, and it's going to take in n as a parameter. And so takes in n as a parameter, and this is going to represent the number of binary numbers that we want to generate starting from 1. That is now what that n is going to represent. And the next step for us here is to now initialize our queue. And to initialize our queue, we're going to use the dequeue. So we're going to basically declare and initialize our queue. So we'll use dequeue. And here now we can basically now initialize our queue, and we can initialize it with 1, like that. So here we initialize our queue with 1. And the idea is that at each step, we will remove a number from the front of the queue, generate its next two binary numbers. So by appending 0 and 1, and those new numbers back into the queue. Yeah, I hope that makes sense. So the next thing we're going to do is also initialize our result list. And we're going to initialize our result list so that we can store binary numbers that we generate. And we'll append each binary number to this list as we remove it from the queue. So we're going to initialize our result list here. So we're going to have it as an empty list for a start. And the next step from here, which is going to be now looping through the n iterations that we've specified at the beginning. So for that, we can just say for underscore in range, and it's going to take in n. So it's going to take in n, and we're going to ensure that it generates exactly n binary numbers. That is why we're using this iteration. That's why we're doing it. So each iteration corresponds to generating the next binary number. And now inside of this iteration, we're going to do a number of things. So in each iteration, we're going to basically remove and return the front element from the queue. And this is the binary number that was added in the previous step, right? So what we do here is we're going to declare of the front basically, and we'll use the pop left. So queue has a pop left function here, and like this. So this again, like I've mentioned, is going to remove and return the front of the queue from the queue, right? And how we do that, the next step after doing this is going to be now appending this to our result. So we're going to just do result dot append. So we are appending the numbers here now. So append front in this case, right? So after doing all this, basically we are following the FIFO pattern, or the FIFO principle in this case of the queue, which ensures that we generate and process binary numbers in the correct order. Right? Just to reiterate on this as well, at each iteration that we're doing here, we're using the queue dot pop left to remove and return the front element from the queue. So remove and return the front element from the queue, and this is the binary number that was that we added basically in our previous step, right? So the next step from here is going to be for us now to try and generate the next two, to try and generate the next two binary numbers. So to do that, we're going to just say q dot append. So q dot append. So we're appending front plus, and we add zero. Again, you do understand binary numbers as zeros and ones, and then we do q dot append. Then also going to append front plus one. So let me just add that space there. Yeah, so after removing the front element, we generate the next two binary numbers by appending 0 and 1 to the front element, right? So again, we already declared the front element here. And for example, if the front now, if the front element is 1, let's say, let's just have an example here. So for example, if the front element is 1, we create two new binary numbers. So the two new binary numbers that we're going to create are going to be 10 and one, basically 10 and 11. We then enqueue these new binary numbers back to the queue. So this is going to ensure that they will be processed in future iterations of the loop. Again, remember, all this is still happening inside our iteration, right? And the next thing that we're going to do now after this iteration, after we finish the iteration, we're going to basically now return the result. And returning the results, because the reason we're returning it, it's because it's the one that contains all the binary numbers from 1 up to the n that we're going to specify when we call our function. So we can do that here now. And we can specify the value of n earlier. So, or we can even get an input from a user. So let's say, just say n here, and we can use the input function to tell our user, please, it should be a speech mark. So we tell our user, please enter a number. And once a user has entered a number, we're going to let's just print out this list. So we're going to call the generate underscore binary numbers function that we declared, and we're going to pass in the n that we've gotten from the user there. So from here now, let's run our code so we can see the output that we're getting. So it's queues.py. So please enter a number. If I enter a number like 5, so we're getting type error. Oh yeah, the reason we're getting this is because we need to do some type casting here, because when you're using the input function, by default, even if you enter a number, it's going to come to be returned as a string. So we need to basically just do some type casting here. Now once you've done that and we run this again, please enter a number. We enter 5. Now you see we've gotten the results that we expected, which are binary representations from 1 to 5. If you want to do binary representation from 1 to 10, you do that, and these are the binary representations that you get from 1 to 10. So just to summarize what you've done up to this point, our code uses a queue to efficiently generate binary numbers. As you've seen, these are the binary numbers, and we are leveraging the FIFO principle to queue to basically maintain the correct order. And we're using string concatenation, of course, which you're doing here, using this to create the next two binary numbers in each iteration. So this is just an example of how you can use the queue data structure to solve problems that you come across. There are many more implementations of this that we're going to look at some point after we are done with this series. Thank you, and I'll see you in the next one.